All right, everyone. So in this example, we have a block of ice that's going to hit another block of ice that's sitting at rest. And when they hit, they're going to go off at different angles. So we want to calculate basically the velocity of B. We want to calculate the magnitude of its velocity and the angle at which it is going to travel after the collision. So to do this, we're going to have to use momentum conservation. And we're going to have to do that for each dimension, for the x dimension and for the y dimension. So it's important to notice that at the beginning, before the collision, we have only x momentum and no y momentum. The y momentum is 0. After the collision, we have both x and y momentum. So we're going to use this to set up two equations and solve for b and the angle. So if we start by considering the y momentum, the initial y momentum is 0, and the final y momentum is the sum of the momentums of A and B. If we take up essentially to be the positive y direction, then we can determine the velocity of A in that direction, and we know everything else except for the velocity of B. So we can determine the y velocity of B. So you find the y component of the velocity to be 0.833 meters per second. Now if we consider the x component, initially B is at rest, so there is no x momentum initially. A is the only thing supplying the initial x momentum. The final momentums can be found by just adding the x momenta for A and B. And so if we solve for the x component of B, we get 1.89 meters per second. We now have the x and y component of the velocity. And so we can combine those components to find the magnitude of the velocity, and then use those components in inverse tangent to find the angle. So to find the angle, we can do the inverse tangent of negative 0.833 divided by 1.89, or the y component of the velocity divided by the x component of the velocity. We find the angle is negative 23.79 degrees, and then we just use the Pythagorean theorem to find the magnitude of the velocity. And so the final velocity is 2.07 meters per second at negative 23.79 degrees.